Hello and welcome to our lesson on adding and subtracting radicals. Basically what we're doing in this lesson is combining the simplifying that we've been doing with operations like adding and subtracting, and then toward the end of the lesson you're going to see all of the operations come into play. So we've already looked at multiplying and dividing, but now we're going to see multiplication, division, addition, and subtraction possibly all together in one problem. So before we can combine all those operations, how do we add or subtract radicals? The good news is this adding and subtracting it's adding and subtracting. Okay, so the same way we add and subtract terms in polynomial expressions is going to be what we do here for radicals. For instance, if you were going to add, let's say, a 5x and a 3x, when you're adding these like terms, what you're combining are their coefficients, right? So 5x's and 3x's all together would make 8x's. The same is going to work for radicals. So if you had, let's say, 5 radical 2's, think about radical 2's like x's, and then you had 3 more radical 2's, then you would have altogether 8 of those radical 2's. So you're going to treat the radicals the same way you treat x's or variables in general. And similarly, if you had, let's say, 5x plus 3y, well, if those weren't like terms, you couldn't combine them, and so you'd still have a 5x and a 3y. Radicals work the same. If you had, let's say, a 5 radical 2 and then a 3 radical 7, if these radicals aren't the same, you cannot combine their coefficients. So this is as simplified as it would get, 5 radical 2 plus 3 radical 7. Now sometimes, at first glance, it doesn't look like you could combine any like radicals. For instance, let's say I wanted you to add a radical 2 with a radical 8. Okay, you definitely could not combine those as is, but the radical 8 is something that we could simplify. So 2 goes in there 4 times, which means a 2 could come out of that radical. So you'd be looking at a radical 2 plus, technically this would become a 2 radical 2. And now that there's the radical is simplified, you could see these are like radicals, so you could combine them. So 1 radical 2 here plus 2 more radical 2's would give you 3 radical 2's altogether. Now, just so you have a way to sort of verify your work, the calculator is not going to do this for you. However, you can verify some decimal amounts. So what I just said is that radical 2 plus a radical 8 would be equal to 3 radical 2. So I'm going to put both of those into decimals here, and you could see that they are both approximately 4.24. So the decimal amounts are the same. So while your calculator won't simplify the radicals and give you the exact answer there, you could put these radicals into the calculator and verify the approximate amounts. Okay, so let's go back here. We want to, before we add or subtract, make sure that everything is simplified. So we're going to simplify all of our radicals if that's possible. And then we are going to add or subtract the like radicals, and we do that by combining their coefficients. So just like if we add x's, 5x and 3x makes 8x, the x doesn't change, it doesn't become an x squared or anything like that. The radicals won't change. The radicals, the radicands, will not change. Okay? That's with addition and subtraction. So, for example, number 1, we have a radical 2. We have 1 radical 2, just like in front of an x when you don't see the coefficient, it's a 1. So if I have 1 radical 2 and I want to add 5 more radical 2's, then I have 6 radical 2's altogether. Now clearly on number 2 we're going to have to do some simplifying, not going to be as simple as the first one. So let's try to break these down. 27 is 3 times 9. 9 is 3 times 3, that means a 3 is going to come out, a 3 is going to stay in. So the radical 27 becomes 3 radical 3's. And then 75 is 3 times 25, and 25 is 5 times 5, so 5 comes out and a 3 stays in. Now be careful because there's already a coefficient of 3 here, so 5 times that 3 makes this 15 radical 3's. And then we don't have to do anything to simplify this last one, so I'm just going to bring down the minus radical 3. And now these are like radicals, so we're going to combine them all by combining their coefficients. So this is going to be 3 plus 15, which is 18. 18 minus the 1, that's a 1 there, is going to give us 17 radical 3's. Okay? So 17 radical 3 is our one simplified solution. Alright, cube roots work the same, we just know if we're breaking them down that we're looking for groups of 3. So let's try to simplify. I can't simplify the cube root of 4, but 32 for sure. 2 goes in 16 times, that becomes 2 times 8, and then 2 times 4, and then 2 times 2. So I'm going to be able to take out a 2 there and multiply by the negative 2 that's already out there. So I'm going to bring down my cube root of 4, and now I have here 2 times the negative 2 is going to make a negative 4 outside of my cube root of 2, and 2 makes 4 again. And now let me take care of this 54. 54 is 2 times 27, which is 3 times 9 and 3 times 3. So a 3 is going to come out and a 2 is going to stay in. So this becomes a plus 3 cube root of 2. So now when I try to combine here, I'm not going to be able to combine the one I have in pink. That cube root of 2 is not a like radical with the cube root of 4. So we're going to be able to combine these first two, but not the last one. So we're going to combine the 1 here and the minus 4 here. 1 minus 4 is going to give me negative 3 cube roots of 4, and then the plus 3 cube root of 2 will just come down. So that's going to be my final answer on that one. And let me just box this in over here too. Sometimes, I don't know why I don't start by boxing things in, and then I gotta go back. Whatever, you're just gonna have to deal with my crazy people. Okay, if you're feeling alright with this process so far, this is a good spot for you to pause the video and try this out. If not, let's see. 24 is 2 times 12, which is 2 times 6 and 2 times 3, so a 2 is gonna come out. Multiply by the 2 that's already there, which makes 4, and then square root of 6 is left over. And then here, 96 is 2 and 48. That's 2 and 24. That's 2 and 12, 2 and 6, and then 2 and 3. So you're going to be able to take out a 2 and another 2, so that's 4. 4 times the negative makes a negative 4 in front of the square root of 6 is left over again. And then the plus radical 6 can just come down, so plus a radical 6. So these are all like radicals, which means we can combine them all by putting together their coefficients. So 4 minus 4 is 0. 0 plus the 1 leaves us with just 1. We don't need to put the 1 there, just 1 radical 6 for our answer. Now if that 1 radical 6 hadn't been there, if it was just these two terms, then our answer would be 0. Technically it'd be 0 radical 6, but 0 times anything would still be 0. Just so we're clear. Okay. Moving right along, we're going to throw some variables in there. It doesn't change our process. We're still going to simplify, looking for groups of 2s or 3s or whatever based on the index, and then we're going to combine the coefficients of our like radicals. It just looks a little uglier here. Alright, so for example, let's see, this is 2 times 9, and 9 is 3 times 3, and then I also have 3 x's here, so I'm going to be able to take out a 3 and an x, and I'll have a 2 and an x left over. So I have 3x and then square root of 2x for my first radical. And then the second one doesn't simplify, so I'm just going to bring down my plus 4x square root of 2x. So these are like radicals. I will now combine them by combining their coefficients. So 3x plus the 4x gives me 7x in front of my square root of 2x. Not so bad. Again, just looks a little ugly. Let's see. 3 radicals in here. Try to make this fun, right? So this is 2 times 4, which means a 2 is going to come out, but a 2 and that x is going to be stuck in there. So 2 times the x squared is going to give me 2x squared in front of my square root of, again, 2 and x are left over. Okay, second radical. I can't break down the 2, but if I have 3 x's in there, one of those comes out. Multiplied by the 3x that's out there gives me a 3x squared in front of my square root of that 2 and x is left. And then lastly here, 50 is 2 times 25, which means a 5 is going to come out. And if I have 5 x's, then 2 of those will come out as well. So there's a minus 5x squared coming out, and then a square root of 2 and x left again. So these are all like radicals. Again, now I can combine their coefficients. So 2x squared plus 3x squared makes 5x squared. 5x squared minus 5x squared gives me 0 in front of my radical 2x. But again, 0 times anything is just 0. So our answer is 0. All that work for everything to cancel out. It happens, obviously. Okay, let's see. Let's try this guy. 8, I'm hoping you don't have to break that down. The cube root of 8 you should know is 2, but just so you could see it, and if you weren't sure, right, a 2 is going to come out. There won't be anything left in terms of numbers. And you've got 4 x's in there, so one group of those will come out. So the first radical becomes a 2x in front of the cube root of x. And then here, 125 again. Hopefully you don't have to break that down. The cube root of 125 is 5. But you can see it if you break down. A 5 is going to come out. Nothing will be left in terms of numbers. And that x is going to be stuck there. So that's going to be a negative 5. And then in front of a cube root of just an x. Okay, so here we have an interesting situation. These are like radicals, but in order to combine their coefficients, the coefficients would have to be like terms as well. So this, we have two options. We could literally leave this as is because the 2x and the 5, the coefficients are not like terms. We can't combine them. So I could leave my answer as is, or because those two terms have a cube root of x in common, we could factor that cube root of x out. So if the cube root of x came out, then I would have a 2x minus 5 left over. So either one of these would be perfectly acceptable answers. I'm totally fine with whichever way you want to leave it. So if you prefer this step because maybe this wasn't jumping out at you, that's totally okay. Just recognize that this is equivalent to this one. Okay? So I don't care which way the answer is given, but you should recognize that they are the same so that if you had, let's say, a multiple choice question on a quiz, that you could recognize either one of those would be correct. Okay? Alright, last one on the front here. If you want to try this again, if you're feeling confident, then give it a shot. Let's see. 28 is 2 times 14, and since that's 2 times 7, a 2 is going to come out. That x is going to be stuck there, so our first radical becomes a 2, and an x in front of a square root of a 7x. And then next, 63. 3 goes in 21 times, and then that becomes 3 times 7, so a 3 will come out. And if I have 3 x's in there, one of those comes out as well. So that's going to be a minus 3x in front of a square root of 7x. And now these are like radicals. I can combine their coefficients, which are also like terms. So the 2x minus the 1x, or 3x leaves me a minus 1x in front of the square root of 7x. And there we have it. Okay? So we've now taken care of all 4 operations. We know how to add, subtract, multiply, and divide radicals. So where we're going to go next is combining some of those operations. So when you're combining operations, follow the general order of operations, right? So parentheses, exponents, multiply, divide, add, subtract is general rule for not just numbers, but for polynomials, okay? Just make sure that your denominators are rationalized. We've talked about rationalizing the denominators before. We're just going to see a new situation here. Make sure your denominators are rationalized. Make sure answers are simplified. So make sure you don't have any radicals that can be broken down. And then the last 2 bullets we're going to come back to. Okay? So for example, let's look at number 7. We've got 2 operations in here. There's obviously addition inside the parentheses, and then there's multiplication here with that radical 2. So technically we would want to work inside the parentheses first, but since we can't actually add a 3 with a radical 5, then we're going to go ahead and multiply. We're going to distribute. Excuse me. So a radical 2 times 3 is going to be 3 radical 2, and then a radical 2 times a radical 5 is going to make a radical 10. So remember, when we're multiplying with radicals, the coefficients here, the 1 and the 3 would get multiplied and stay as a coefficient, and the radical, or the radicand, would stay as a 2. And then when you multiply here, your radicands get multiplied, so the 2 times the 5 makes the 10. Hopefully that is not gone from your memory because it wasn't too long ago. Okay, so radical 3 radical 2 plus radical 10 is where we stand now. Since the radical 2 doesn't simplify and the radical 10 doesn't simplify, there's no way that we could actually combine these. There's no way to make them like radicals, which means that is the answer. It's as far as we could go for number 7. So sometimes it's that simple. Okay, sometimes it requires a little more work, like number 8. Again, we cannot do the subtraction or addition in the parentheses because none of those are like terms. So we're going to go ahead and do our multiplication. So first here, 2 radical 3 times 4. The 2 times the 4 is going to make 8 in front of the radical 3. And then 2 radical 3 times 3 radical 3. So the 2 times the 3 on the outside is going to give me 6, and the 3 times the 3 on the inside is going to give me radical 9. And then negative 1 times 4 is going to make a negative 4. And then finally, negative 1 times 3 radical 3 is going to make a negative 3 outside of my radical 3. Alright, so now, if there's any radicals to simplify, we want to do that. And if we have any like radicals, we can take care of those, or combine those as well. I would probably fix this 6 radical 9 first, because the square root of 9 is just 3. So this is really just 6 times 3, which makes this 18. So now when I go to combine, I have 8 radical 3's here that I could put together with the negative 3 radical 3's here. So 8 minus 3 is going to give me 5 radical 3's. And then I can definitely combine my coefficients here. So, sorry, not coefficients, my constants here. So I have 18, and I have negative 4, and 18 minus 4 is going to give me a positive 14. And that is as far as we can go with that. So 5 radical 3's plus 14. Okay, number 9 is going to be pretty similar. You might be tempted to just square this and square this, but when we're squaring a binomial, remember it means to multiply it by itself. So we want to take a radical 7 plus 4 and multiply it by itself by another radical 7 plus 4. So again, just like the previous problem, where we're going to distribute. Radical 7 makes radical 49. And radical 7 times 4 is 4 radical 7. Again here, 4 times radical 7 is 4 radical 7. And then lastly here, 4 times 4 makes a positive 16. So the square root of 7 over here, or 49 over here, we know is just going to be 7. So I can combine those constants, the 7 and the 16, which is going to give me 23. And I can also combine my like radicals here. 4 radical 7's plus 4 more radical 7's is going to give me 8 radical 7's altogether. And those aren't like radicals, not like terms at all. We can't combine them, so that's as far as we can go with that one. And just so we can see it again, your calculator is not going to simplify the radicals for you, but if you want to verify, then type in the original and the ending expressions into your calculator and verify the approximate amounts. So let's go ahead and verify that radical 7 plus 4 quantity squared and 23 plus 8 radical 7 are actually equivalent, and you can see they are. The decimal values are exactly the same. So if you want a way to verify, make sure your beginning and ending expressions have the same approximate value using the calculator. Okay, one for you to try. So feel free to pause and give this a shot. Alright, so if we multiply here, these are, if you remember, these are called conjugates. When you are multiplying the same terms with the opposite signs. Hopefully you remember what happens when you multiply conjugates. So radical 6 and radical 6 gives me radical 36. And then radical 6 times negative 5 is a negative 5 radical 6. And then here we're going to get a positive 5 radical 6. And then at the end here, 5 times negative 5 gives me a minus 25. So what happens is our like terms in the middle, they cancel. And so all we're left with is radical 36, which is 6, and we can combine that with the negative 25 here, and so we end up with negative 19 for an answer. And again, if you just want to verify, this is a good idea. It seems strange, right, that we ended up without any radicals here. So let's see. Radical 6 plus 5. And we're going to multiply by radical 6 minus, oops, gosh, backwards, minus 5. And in fact, we get negative 19. So it's verified there. So when you multiply the conjugates, we remember the middle terms cancel. And we ended up without, even though we started with radicals, we ended up without any radicals in our answer. That's going to be a helpful thing in just a few moments. So when you multiply conjugates, the middle terms cancel. So middle terms cancel. when conjugates are multiplied. Remember the differences of squares that we were factored into these conjugates. That's the only way to get those middle terms to cancel. Okay, so that's going to be helpful here. If we look at number 10, we've got addition in the numerator, we've got addition in the denominator, but we cannot do the addition because those aren't like terms. And we also have some division in there. And I can't nicely divide 3 plus radical 3 by a radical 5 plus 1. But this is an irrational denominator. We want to rationalize this denominator. So the goal, we've done this before, but it was a little simpler. If we had something like just, let's say, a 3 over radical 5, we said, well, we can multiply by radical 5 over radical 5 because this has a value of 1, and multiplying by 1 wouldn't change the value of my fraction. But they got rid of the radical from the denominator. So I had a 3 radical 5 on the top, but a radical 25 on the bottom, which is just 5. So we were able to rationalize the denominator by multiplying by a form of 1. So that's what we're going to do again here. We're going to multiply by a form of 1, but the form of 1 we're going to use is the conjugate of our denominator. If I want this to be just a rational number instead of this irrational with the radical, I'm going to multiply by its conjugate, because when you multiply by the conjugate, what happens to the radicals is they cancel. We end up with the perfect square in the beginning, so that radical goes away, and you end up with the radicals that are going to cancel from the middle. So we're going to multiply this fraction. We're going to rationalize this binomial denominator by multiplying by the conjugate of the denominator. So we're going to multiply by a radical 5 minus 1 and a radical 5 minus 1. Alright, so now we get to apply the process we just looked at. So on the top, 3 times radical 5 is 3 radical 5. 3 times negative 1 makes a negative 3. Radical 3 times radical 5 makes a radical 15. And then radical 3 times negative 1 makes a negative radical 3. So there's our numerator. There's already a mess, right? Let's go to our denominator. Radical 5 times radical 5 makes radical 25. And then I know that this negative radical 5 and positive radical 5 are going to cancel. So if you wanted to skip those, you could, but I want to have thorough notes here. So we have a minus radical 5 and a plus radical 5, which will cancel. And then 1 times negative 1 makes a negative 1. Now we just got to clean this up because it's a mess. So on the top of the fraction, I don't have any like terms or anything that I can combine. No like radicals, no like terms. So the top's going to stay as is. 3 radical 5, and I don't descending order, I'm not really worried about it because you'd have to approximate those radicals in the calculator. Don't worry about that. Okay, on the bottom, we can definitely simplify. So we know that these we're going to cancel, positive radical 5, negative radical 5, and then the square root of 25 here is 5, which we can combine with the negative 1. So 5 minus the 1 makes my denominator a 4, and none of that reduces, so that, ugly as it may look, is our answer. Okay, and again, that could be verified with the calculator. And I could make that go this way. There we go. Alright, so let's try another one, or if you feel good about this, I don't have so much going on in the numerator, this might be a little bit easier to work on here, but if not, we're going to, again, multiply by the conjugate of our denominator to rationalize here, since we can't actually do any division or addition. So we're going to multiply by 4 minus radical 2 and 4 minus radical 2. So on the top of the fraction, radical 7 times 4 is going to be 4 radical 7. And radical 7 times a negative radical 2 is going to be a negative radical 14. And then on the bottom, we have 4 times 4, which is 16. 4 times a negative radical 2 is negative 4 radical 2. And then here we get our positive 4 radical 2. So again, if we knew those were going to cancel and you wanted to skip those, that would be fine. And then at the end here, radical 2 times a negative radical 2 makes a negative radical 4. So where are we going from here? Can't simplify anything on the numerator. So again, 4 radical 7 and minus radical 14 are going to stay. And then in our denominator, these will cancel, right? Positive and negative 4 cancel. And we know that this radical 4 is really just a 2 here, so it's a minus 2. So the 16 minus the 2 leaves me a 14 to go in my denominator. Okay, nothing to reduce there, so we're good. Now I do want to point out, I'm sorry I didn't make one of these happen, but let's just say you had a fraction that was like a 4 radical 7 minus a 2 radical 3 or something, and a 14 in the bottom. In this particular case, you have 1, 2, 3 terms in the fraction, and their coefficients, right, the 4, negative 2, and 14, they all have something in common. So if that happens, then you can reduce. So this one would become, if you reduce those coefficients all by 2, it'd become a 2 radical 7 minus a 1 radical 3, and then a 7 on the bottom. So what you want to be looking for is the coefficients of the radicals, or the constants. If those all have something in common, then you can reduce. But if you look here, we've got a 4, and then a minus 1 and a 14, and that 1 won't be divisible by anything, so that's not reducible. But if those 3 coefficients, or the 2 coefficients, the constants, have something in common, then you can reduce. Okay? So only reduce when all of the terms have something in common. And I think we left some bullets blank up here, so let's go back to the beginning. Yep, we did. Alright, so if we want to rationalize a binomial denominator, then we're going to multiply the numerator and denominator by the conjugate of the denominator. And the conjugate of the denominator, remember, has the same terms and opposite signs. So for example, the conjugate of a plus b would be a minus b, where you keep those terms the same, just change the sign in the middle. Okay? Or if you had like a radical 3 plus 1, then it would be a radical 3 minus 1. Or if it was like a, I don't know, like a 2 minus a radical 7, then you'd multiply by a 2 plus radical 7. So same terms, just opposite signs. Alright? So there it is. We've got all 4 operations individually, and we've combined a few. Hopefully that'll be enough for you to get going on your practice. But if you are working and you're struggling, then as always, just reach out for some help. I'm here. Alright guys, take care.